Hello everybody, and we'll start in a couple minutes here once 10:40 rolls around. But today we're going to be talking about simple and compound interest. Not too difficult of topics. But for some reason people don't like compound interest. Alright, well it's 10:40 so I'm starting. Welcome to Simple and Compound Interest. There is a slideshow that goes with this, so if you want to take notes you can, or if you just want to I'll look off that slideshow and follow along, that'd be great too. These are two topics that are very closely related yet very different. So let's just start talking about interest in general. When it comes to interest, interest deals with investments. If you ever get into finances or anything like that, which hopefully all of you at some point will do, just because it's a smart thing to do, is to keep track of your money and have your money actually work for you and make money while you don't do anything. But yeah, investments are a big part of our economy. Not so much right now because our economy doesn't really exist, but we do have investments. So what you're going to do is, if you go to a bank or something and you open up a savings account, your savings account is going to earn interest. And interest is the fact, well, a savings account works by, hey, I'm going to loan the bank money. I have money, I'm going to give it to the bank for the bank to use. Your money doesn't actually exist physically in the bank. It exists as a number on a computer, but it keeps track of it, and you should probably have your own records of it as well. But if you invest money in a bank, like a savings account or something, the bank holds on to that money, and when people come to the bank for loans, they loan out your money to those other people, and the bank actually pays you interest to use your money. So that's why it's a good idea to put things in a bank as opposed to just throwing it under your bed or burying it in the backyard, because while your money sits in a bank, the bank is using it and paying you to use your money, and that payment is called interest. So there are two types of interest. There are simple interest and compound interest when it comes to these kind of investments. You also see interest in other places. For example, you might get charged interest if you're borrowing someone else's money, right? They're going to expect you to pay them just to borrow their money. So if you use like a credit card or something, you're being charged interest on that. And we'll look at that end of it tomorrow a bit. But let's look at simple and compound interest today. They are both formulas. So they are formulas. You have a formula for simple interest. which we looked at briefly yesterday. If you hung around for everything, it's going to say interest equals PRT. And it's a simple formula for it. And you also have a formula for compound interest, which is a bit more of a complex formula. But it's still a formula nonetheless, which is B equals P times the quantity 1 plus R to the nth power. They are both just formulas, and you handle formulas the same way you handle every other formula you have. You figure out what you know and what you don't know, and you plug in and solve for what you don't know. You could do what we did yesterday and manipulate these formulas beforehand to solve for what you want, or you could manipulate it as you go, which is probably what most of us are going to do. The reason you want to transform formulas beforehand is if you're doing a whole bunch of problems that are all similar, like, hey, I'm doing a whole bunch of simple interest problems and they're all asking for the p-value. In that case, I'm going to transform this to solve for p, and then I can just plug it in and chug it out and don't have to worry about any of the algebra. I can just do the operations right away. But let's look at what these letters stand for. So over here for simple interest, your I equals your interest. This is how much money they're going to pay you just for having your money invested. This is how much money your money makes, so to speak. P stands for your principal. And your principal is your original investment. So, for example, if I'm opening a savings account and I'm putting $500 in it, my principal is the $500. It's how much I originally put in. R is your rate. This is usually a percentage. It's usually given to you as a percentage. Once you find that percentage, make it a decimal. But sometimes it gives you the decimal. We're only going to be working with the decimal for it. So for example, my investment of $500 is going to earn interest at a rate of 3% each year. So what that means is that after 1 year, that $500 has grown by 3%. So I find what 3% of $500 is, add it on to the $500, and you get your bank account, or however much money is in there. And T is going to go for time. So this is how long it's invested. And when it comes to simple interest, this has to be in years. So keep that in mind. That has to be in years. So that's for simple interest. For compound interest, it's a little different than simple interest. Simple interest is, say you have the $500. After 1 year, you get 3% interest. It adds 3% on. So 500 plus the 3%. After 2 years, you'll get another 3%. So it adds 500 plus your original 3% that you got your first year, plus another 3% you got your second year. Compound interest, it compounds it. So what it does is your $500 gets invested. After 1 year, you get 3%. So there's no difference after 1 year or one period of compounding, whatever that might be. Then after the next year, you earn 3% on your account balance as opposed to your principal investment. So this keeps earning based off of that principal investment. Compound interest keeps earning off of the earnings that you have. This here is a better investment. If you can get something compounded more often, the better it is, because more often you get the interest and it gets added on. I mean, both of them are good investments. It's just that if you can get an account with compound interest over simple interest, you're going to make more money. It is the better of the investment. But here we have B is equal to your balance. So that's how much money is in your account. So that's money in account. P is your principal. That's still how much you originally invested. The number 1 there, this number here, is a constant. It is always going to be there. And that's going to the reason that's 1 is because that represents 100% of your account to begin with, and then you're going to add on to it. But that is more of getting into exponential equations, which will be next year, on why that's a 1 there. R is going to be equal to your rate, which again is normally given to you as a percent, but you want to make a decimal. And N is your number of times compounded. And that's a little different than it's going to relate to your time over here. It is a little different because let's say we compound things 4 times a year, then it's going to be 4. It's not going to be 1 for years. So it depends on what it is. So that's your basic information on what you need to know about your formulas. Well, let's do some examples of them so you know how to use your formulas. So let's start off with, how do I want to do this? Let's take this and hide it in another layer. And save that for later. Let's look at simple interest first. So here, this is simple interest. Our example problem, again, if you're following along in the PowerPoint, it's going to have this problem in there as well. But let's say, I can just copy that over. Actually, let's copy all of it. Let's move it over here and hope my face is not in the way. Let me double check that. Yeah, my face isn't in the way. You can see all that. Let's see, switch layers. What layer do I want? That layer. This layer. Let's go with this layer. I think this is the other layer. Yeah, good. Okay, so here we have our problem, and we're going to answer our questions to it. We actually have the numbers in copy. We have question A, we have question B, we have question C, and we have question D. So we're going to answer all 3 of these questions. Yeah, that bullet's in copy over. So let's look at the information given. Suppose you deposit $400. Right away, I know that's my initial deposit. That is my principal. So I'm using simple interest, right? Because it's asking about simple interest here. So I am using the formula interest equals PRT. That's the formula I'm using. It's telling me that my principal investment is $400. I'm getting that from right here. I deposit $400. That's my original deposit. In a savings account, it's telling me that it's simple interest, so I'm using that formula. And the interest rate is 5% per year. So I'm saying my rate in this case is 5%. However, I don't want to use it as a percent. I want to make this a decimal. So make this a decimal, and you should be able to do that in your head by moving your decimal point 2 places. Okay. So I'm going to make that a decimal and work with the decimal. I never work with the actual percent. I always make it a decimal and work with the decimal. After that, that's the information that's given. It is telling me that it is per year, which is going to play an effect. So I am going to just kind of keep a note of that. But I don't know my time right now because it's not, there's no question. So the question here is going to be A, how much simple interest is earned in 6 years. So in that case, for A, my time is going to equal 6. Because remember, it has to be in years. 6 is in years, so it's going to work. Once I get my information organized, I'm just going to plug into my formula. So interest equals P. P is 400. R is 5%, but again, I can't work with the percent. I want to make it the decimal. 0.05. And T is 6. And then I can just solve for I. So I can just multiply all those up. And you should be getting an interest equals 120. And this is going to be money. Right, 5% does not have a unit. 6 is years. And it's going to be money. So what this tells you is after 6 years, it got an interest of $120. So how much is the simple interest earned after 6 years? This here is $120. Question B says, after 6 years, how much is the account worth? Okay, so that is just some reasoning you got to go through. You know that you originally deposited $400, and after 6 years, you made $120 more. So for this, you're just going to do 400, which is your initial investment, plus the 120, and you're going to get the $520. Next, part C says find the interest earned in 3 months. Well, this is a little different now. Our time is changing, but you got to remember that our time here is in years, and this is giving it 3 months. So what you got to do is you got to convert 3 months to years. So 3 months time equals 3 months, which is also equal to, well, there's 12 months in a year, so that would be 3 out of 12 months of the year, which equals 1/4. So 3 months is 1/4. And again, if you don't like the fraction, you can make that as the decimal. 1/4 is 0.75. And you can get that by just dividing 1 divided by 4. So this here is the number we're going to plug in for time now. So here, same deal. Interest is going to equal your principal investment, which is $400, times your rate, which is 0.05, times your time, but again, it has to be in years, so you got to use the 0.75. We just got to change 3 months into years. And again, you could have done your whole dimensional analysis with that, or you could have just kind of reasoned through it like I did. 3 months out of 12, and then set up the ratio for that. Yeah, I'll do some practice problems. Let me get through how to do these first. Because again, even if their people aren't viewing this, they have it to go back and look at. So let me get through the actual lesson today first, and then we'll look at your assignment. So 400 times 0.05 times 0.75 gives me $15. So after 3 months, I make $15. So here interest equals $15. So after 3 months, I make $15. And remember, how much is the account worth? It's going to be your original investment plus your interest. So my account is worth $415. Again, 400 being my original investment. So that's kind of how you do simple interest problems. And again, compound interest isn't going to be much different. It's still a formula. The formula just changes. So let's look at a compound interest problem. And I want to get rid of everything I can over here. Watch me mess up my layers. I no longer want that layer. I want that layer. And I no longer want that layer. And let's this. Over here, just so we have it as a reference. And let's get a text layer in here. And let's look at this compound interest problem. So here we have our compound interest problem again, and again it's telling me it's compounded semi-annually, so that interest compounded, whenever you see the compounded interest, we're gonna do that. Yeah, Anthony, we will do more examples. Let me get an example of compound interest. It is just plugging into a formula and solving, but yeah, we'll be here. It's not too difficult, it just takes some practice. So our formula here is b equals p times 1 plus r all to the nth, and you just want to plug into this to solve. This is a little more difficult to solve because you have the exponent, but you should be okay with it. So balance is going to be the money in the account. I don't know what that is here because it's asking me to find the balance. So I don't know what the balance is here. So I'm going to leave that as B. Is unknown. Our principal amount here, our P, our principal investment is the $1,000. So I'm putting $1,000 in. 1 is a constant. R is our rate, which again is given to you as a percentage. However, we want to make a decimal. So that is equal to 0.06 as a decimal. And is compounded semi-annually for 5 years. Now the big keyword here is semi-annually, which means twice a year if you do not know. 2 times a year. And n is the number of times it's been compounded. So if it's been compounded 2 times a year for 5 years, it's been compounded twice a year times 5 years gives you 10 times. So your exponent here is 10. With that, you're just going to plug in and solve. So we don't know what B is. Principal is 1,000. 1,000, that's going to be multiplied by 1 plus your rate, but again, we're using the decimal, 0.06, all to the nth power, which in this case is 10. So just do your order of operations first, parentheses first. So we get B equals 1,000 times 1.06 to the 10th. You're going to do 1.06 to the 10th first. So that equals B equals 1,000 times 1.06 to the 10th gives us about 1.80, and then we're going to multiply that by 1,000. So your balance is going to equal 1, 2, 3. 1, 2, 3 multiplied by 1,000, and you get $1,800. So that's your balance. If you want to know how much interest you made, you need to take it from your original balance. So how much money did my account make? Well, my original investment was 1,000. I'm going to subtract that from my current account. It made $800. So this would be compound interest. It's just using a different formula. Okay, that's all the more is. Just so you have some terminology, if you didn't know what semi-annually is, you can use a dictionary to look up words you do not know, but just I think the ones your book is using is quarterly. Quarterly means 4 times a year, right? If your year was divided into quarters, you have form. This is pretty common to get things that are quarterly because businesses go by a quarterly financial schedule, so they have to post their losses and gains every quarter for stock reasons, for public trading and stuff like that. We also have semi-annually, which we just went over, which is 2 times a year. And then you have annually, which if you didn't know what that meant, is 1 time a year. And you got other words for it too, but I think these are the 3 that the book is using today. So with that, let's look at some of the problems that you guys are having questions on. Your assignment today is page 385, 1 through 15. So would number 1 be $28? I don't know, I didn't look at them yet. Let me pull my book over. We got 385. You're half right on number 1. So let's look at number 1. Just pay attention to what it's asking. It's asking to find simple interest and then find the total of principal plus interest. So we want simple interest. So we want to find what I equals, and then we want to find what your principal plus I equals. So it wants you to do both. So you got to tack on that 28 to your original. Yeah, we'll do a couple. Number 1 is stating that your principal equals 200. That's in dollars. Your rate equals 7%, which again we want as a decimal, so that's 0.07. And your time in years is 2 years. And again, this is simple interest. So use the formula interest equals PRT to solve. Just plug in what you got. Interest equals P, which is 200. R, which is, again, you need to use the decimal version of it. And T, which is already in years, so you don't have to worry about it. And then you just multiply them all together. 2 times 200 is 400. 400 times 0.07 gives you your 28. So your interest was $28. So for the first part of that question, you want 28. The second part is your principal plus your interest. So we're going to take the principal, which is 200, plus the 28, which you got for your interest, and your account balance is $228. So it's actually both of these is your answer. But yeah, 28 is part of it. Okay. And number 2 is done the same way. I believe it is. Yeah, just be careful with number 2. In number 2, it gives you your time in months. So you got to figure out, well, 9 months is 9 out of 12, which is 3/4 of the year. So you're going to be using 3/4 as your number here, which again would be 0.75 for that number. For number 2. Let's see, a couple you asked about number 3 here. So let's look at number 3. 3 states. Complete each table. Compound the interest annually. In your last calculation, round to the nearest tenth. So we have a table, just to quick get it on here. We have principal at start of the year. So we have principal. At start, we have interest. And we have balance. it gives us year 1, year 2, and year 3. And it tells us at the beginning we have $3,000, which is enough. It also tells us above that we start with $3,000. Our rate is 4%, and it's doing it for 3 years, which that information is here as well. So again, before you do anything, your rate needs to be a decimal, so we're actually using this. Again, just divide that by 100 and you'll get your decimal. We're actually going to find our balance first, because our formula solves for balance. Balance equals principal times 1 plus r to the nth. And then we'll find our interest from that. So let's do our first one. Our principal is 300. Our rate, this is going to be our rate. And then depending on, it's compounded yearly, so this will be compounded once, this will be compounded twice, and this will be compounded 3 times. And we'll get our interest as we go. Here we got B equals, P is equal to 3,000, so I'm plugging in 3,000. 1 plus R I can do right away because I'm just adding 1 to it. Hopefully that didn't screw you off. That was the easy part. And n, for our first year, our n is going to be 1. Anything to the first exponent doesn't really matter. And that's why our simple interest doesn't have exponents, because it technically has an exponent of 1 for simple interest. But anyways, 3,000 times 1.04 gives us a balance, and again this is balance, this is going over here, of 3120. This is annual compound. Annual just means once a year. So you count how many years pass, it's compounded once every year, so it's going to be once here. To find your interest, you take your balance and you subtract it from your principal, and that will give you your interest. So here we have 3,120. Your principal was 3,000, so 3,120 minus 3,000 gives you 120. So your interest was 120. And that's for year 1. For year 2, you do the same thing, only instead of it being compounded once, it gets compounded twice. So this becomes a 2. In doing so, you can do 1.04 to the second. Just remember your order of operations. You need to do this exponent first. You don't need the brackets there, but just remember your order of operations. You do that first, and then you multiply that by your 3,000, and you are getting a balance of $3,244.80. So you're getting $3,244.80 now. So your total balance here for year 2 is $3,244.80. That is a comma. Dollars. And then to get your interest, again, you're going to take your balance and subtract your principal from it. So let's subtract 3,000 from that, and you're going to get 244.80. So you've earned now $244.80 after 2 years. Your principal amount doesn't change in the sense that, hey, this was year 1. If you wanted to, you could say, hey, this here is my new principal amount, and now this here is 1 year. And let's do it that way as well, because we can move our principal down and hopefully we get the same answer. Because if we're looking at it that way, then we're only compounding it once, but our principal amount is no longer the 300 or the 3,000, it is going to be the 3,120. And if we solve that, hopefully we get that 3244.8. 3120 times 1.04 gives us, yep, that's giving us that 3244.8. So again, if you wanted to think of this as year one and this is your original principal, then that exponent would be after 1 year, and it goes on. But for, I think it's easier to just change the exponent, but you know, if you want, I don't think it's asking you to fill in, yeah, I guess it is. So this number here for year 2, your principal investment, or what you start the year out with, is going to be 3120, because that's what you ended last year at. This one here is going to be 3244.8 because that's what you ended last year at. So you could start with year 1 and plug that in for your principal, or we can continue going with the 3,000, which is what I'm going to do, and just change the exponent as you go. So now it's going to be compounded 3 times. So let's go ahead and solve for our balance for year 3. So again, 1.04 to the third, remembering to do your exponent first. And then you're going to multiply that by 3,000, and it's telling you to round to the nearest cent, probably. I don't remember what it says. Yeah, round to the nearest cent. So this answer is going to give you a balance of 3374.592, which gets rounded to 3374.59. So over here you have 3374.59. And how much interest did it earn? Again, you're going to subtract that from its principal amount. And that's going to be minus your 3,000, which is going to give you 374.59. So again, all those are your answers. It's just asking you to do the problem multiple times with that. Is there another one that someone wants me to go over? We got about 5 minutes left here. But it is just kind of plugging into a formula and solving. Formula work is all the same kind of steps. Just plug in what you know and solve. I don't know if there's anything else that's... Is number 5 similar to number 3? Not really, it's not a table, but I mean it's done the same way. 5 says you have a principal investment of $495, you have a rate of 8%, which I can't use, I need it to be 0.8, and it is compounded annually for 2 years, which means it only gets compounded twice in 2 years. So then you just plug it into over here. B equals 495 times, again, you can probably do that in your head without writing it out, but 1 plus 0.08 to the second, 495, 1.08 to the second. Remember to do your exponents first. 1.08 to the second power, and then multiply that by 495, and you get a balance of 577.368, which again, this is money, so it's going to round to. If you want to round up, the bank probably doesn't round up on you. And it is asking for the balance, so that is B. That should be your answer. And yeah, that's what the book's saying. So yeah. It's similar in the fact that it's the same formula, same kind of problem. It's just asking you for a specific number out of here, I guess. With that, if you have any more questions, shoot me an email. But again, it's just plug into the formula and solve today. If you don't understand something, shoot me an email and I'll get to it. And I'll talk to you later. We're out of time. So long. Bye.